Hi. So like Matt said, I've spent 35 years in data security, and at that point I said, okay, let's retire, and then it was pretty boring, so I said, what am I going to do now? And then AI started, and for me, AI was like a really weird thing, okay? It's like strapping yourself to a rocket, turning it on, and off you go, okay? It's just incredibly powerful, very fast, and also very scary. So it was fun. So that's what I've been doing for the last 5 years or so. And I think if you've been in this space, you've seen the change, right? We started with something that was, like a really good search or an improvement to search, and then it was something that started doing things for us. Okay, we called it Generative AI, and now this thing is just doing everything for us. Okay, that's the agentic side. And there are two things that happen when you look at AI in general and agentic AI. One is about competency. Okay, there is something completely different with what these models are doing. And I for me there was like three phases to this. Okay, the first phase was when GPT-3 became GPT-4, okay? That was a fundamental shift, okay? The level of what it was able to do was just so different. The next one was the first time I saw O1, okay? O1 was the first reasoning model. Until then, it was like a conversational model. And to me, that was important because, I'll tell you something about myself. I am a failed mathematician. I thought I would be a mathematician. I started math, and then I realized I was dumb. I was not smart enough. There were too many smart people in the room. I said, okay, if I can't do math, what can I be good at? Oh, computer science, that's pretty good. That's much easier than math. When you look at O1, and of course what you have now, it is probably smarter than most PhDs in math. So it's certainly smarter than me, okay? And like recently, one of them solved one of the Erdős problems. It's the very famous Hungarian mathematician that has a bunch of conjectures that nobody solved for many decades. Okay, so this thing just solved one of them. And then a week later, another model solved it in a much better way. Okay, so you're talking about competency. Of course, I'm sure everybody in this room has read and been worried about mythos, okay, because holy crap, everything we've ever done around vulnerability management just goes out the window. And then you have Fable. Okay, do you realize that both of these models, Mythos and Fable, which are Anthropic models, were removed 4 days ago? Okay, they were removed 4 days ago because the US government told Anthropic, remove it. Okay, do you know how Anthropic defines itself in terms of, how every company has this DUNS number or whatever, which vertical they're in, and in terms of the safety of their products, Anthropic doesn't view themselves as a software company. Okay, when they say our technology should be classified like this, what do you think they classify their technology as? Okay, they classify it's not that they think they're that kind of company, but they classify their technology like nuclear energy. Okay, so they view this thing as not as a piece of software in terms of the risk, resilience, etc., but like critical infrastructure and nuclear energy. That's the way they view this. Okay, so one thing is about the competency of these models and what they're able to do, which has been going like these are the lines in all kinds of main categories, and the dotted line is like the let's say the smarter of our race. They're like beyond that. Okay, so this is one level of advancements, but then we had the brilliant idea that we'll take all these really smart things and we'll just connect them to everything because we want them to do our job. So the next piece is autonomy. So it's been growing in competency, and now we're saying we want them to be autonomous. Why do we want them to be autonomous? Because, they'll make our life better. So the progress has been going like in two dimensions. One has been on competency and one has been on autonomy. And when you think about autonomy, You say, but autonomy is going to take forever to achieve, right? Because, okay, if competency took 5 years to achieve, competency is harder because competency or autonomy is something that's more like on the physical side of things, okay? It has to be in the physical world or at least the IT world. But the reality is that autonomy has not been hard to achieve, okay? It has not been hard to achieve because it's relying on something that we've been building for 60 years. 60 years, okay? So what is an AI agent? Okay, so I can take the Gartner definition or I can take any weird definition, but honestly, the only important definition is it's what happens when you take an LLM and you give it a computer, okay? Because most of us, when we get hired by a company, what do we get? We get a badge and we get a computer. And we do most of our jobs with our computer, okay? So that's what an AI agent is. You take the LLM, which is the brain, and then you take a computer, which allows it to access anything and run anything and goes to the files and hit the internet, etc. That becomes an agent. Okay, what are we connecting the LLMs to? We're connecting it to computers, but the reason that autonomy is possible is really because of Unix. Okay, so Unix, do you know when Unix was first designed? Anybody have a guess? It's actually amazing. It was designed in 1969. I think most of you weren't born in 1969. Okay, so and we've been building Unix for a very, very, very long time. Okay, and then Linux came along, and so all the weird flavors of Unix went away, SunOS and HPUX and Silicon Graphics, etc. And we were left with something very uniform. And that thing that's uniform, like if you're a Unix person or a Linux person, you go to the shell, and the shell has everything in it. It's got all the kernel drivers. It's got access to applications, it's got access to data and files, it's got access to the internet. It's got these weird pipeline languages which makes everything composable. Okay, and so the minute and the other thing that it has is something that is actually better for agents than for people. So we as people have caused the world to develop GUIs. Why? Because we like GUIs, okay? We don't like to read manuals. We don't like CLIs. Okay, I remember it was like when my first job was in the Unix C++ team, and not when it was created, a bit later at AT&T Bell Labs. And I remember every time I had a question, the answer was always RTFM. Okay, read the fucking manual. Okay, so people do not do well with CLIs. People do not do well with scripting. They do well with GUIs. But guess who does really, really, really well with CLIs? Agents. You can take a model and just send it to read the 1,000 pages of the doc for one command. Have you ever seen the documentation for the find command in Unix? Yeah, it's like tens and tens of pages. Okay, I will never read it. You will never read it. But the freaking agent will read it in a second and know exactly what to do. Okay, so the reason this has all been progressing so fast is because the brain has become really, really smart, and the way to achieve autonomy has become really, really fast also because we had it already. We just didn't know we had it. And then when you take the step later, this isn't just about our computers, okay? Our computers is what we do, and honestly, it's what 80% of what this whole AI agents do. But when you go to Elon Musk and you say, how are you going to achieve your $1 trillion bonus? Do you know what his $1 trillion bonus is tied to? It's tied to a bunch of things like the value of Tesla and how many cars he does. But he also has two more things in the bonus. He has to produce 1 million humanoid robots, okay, Optimi. He needs to produce 1 million of these robots and 1 million self-driving taxis. Okay, and anybody who's looked at the track record for Elon Musk, I'm not betting against this guy. Okay, this is all doable. Now the reason it's doable is also Unix. Okay, what do you think my phone runs? My phone runs Android or iOS. They're both Linux variants. They're both Linux kernels. Okay, Raspberry Pi, Linux kernel. Everything's Linux kernel. So everything in our life is going to get this brain inside, and it's going to be autonomous. So we have competency and autonomy, and they're all happening. There's no way this is not happening. There's no way this is not happening. Okay, now you get to all kinds of really weird scenarios that we're going to ask ourselves, are we okay with this scenario? I'll give you a scenario. Are you okay with taking your laptop, opening it up, putting it so that the camera looks at you when you're sleeping, and have this thing look at you when you're sleeping? Raise of hands who is okay with doing that. Okay, raise your hands on who is not okay doing that. Okay, so let me ask you a question. If you're not okay doing this, what happens if this thing is looking at you, and if you have a heart issue that you will die by the time you wake up, this will find it and call whatever the equivalent of 911 here in the UK is? Is it worth it or not worth it? Maybe. What do you think these watches are? These watches that track your sleep and tell you when you woke up and when you didn't and blah, blah, blah. How is it different? Okay, so this is all getting very, very, and I have these discussions with my wife because I of course like to go all the way to the extreme, and yeah, there's going to be robot nannies and there's going to be this, and she says I'm going to freak out, and I said, why are you going to freak out? This is all happening, okay? But what we need to care about is what that means to us from a security standpoint. So I think the main event that you need to kind of figure out is that there is a new labor layer coming, okay? I don't think anybody in this room should have any doubt that there is a new labor layer coming, okay? Meaning, and you can be in different types of organizations, you can be in different maturities. So, for some of you, this is going to take, for some of you, this is already there. For some of you, it's going to take 6 months. For some of you, it's going to take 2 years. For none of you, is it going to take 5 years. Even if you think you work for the slowest company, in the slowest industry, in the most political place, this is not going to take 5 years. It's going to be much, much faster. And you look at this guy, the reason I put him, this is Boris Cherny. He's the lead developer for Claude Code. Claude Code is one of the better platforms, like one of the top 3 platforms for agentic coding. He says he runs about, he didn't say a number actually, thousands of agents per night to write code, okay, to write code. And when you look at Claude Code is about 500,000 lines of code. At this point, there is not a single line that was written by a person, meaning Claude Code rewrote itself a few times, not once, a few times. Okay, so and by the way, I don't know if it's Claude Code's fault, but the Claude Code code leaked, right? It was published to the internet by mistake because the encoding file was shoved into the NPM package, and maybe even Claude Code did it. Who knows? So the code itself leaked. Do you know how long it took before somebody took the leaked code? The Claude Code is TypeScript. Somebody rewrote it in Rust by using Claude Code in 24 hours. Okay, so you look at this, and you have all kinds of companies. You have companies all the way to the top, like Anthropic, NVIDIA. NVIDIA, the CEO of NVIDIA says that for every real employee, like a person employee, there will be 3,000 AI agents in his company. Now, of course, he doesn't give a shit because he doesn't have to pay for the tokens, okay? Because he makes the stuff that produces the tokens, so that's okay. We're not all the same, but we're all going to be somewhere on the spectrum. Okay, and so that's happening. It's just happening. All your organizations are doing this, whether you know it or not. Okay, so the question then becomes, and let me ask you a question first. What, in your opinion, as cybersecurity professionals, what is your weakest link? Weakest link in security? I can't hear. Yeah, exactly. It's the human element, okay? People are the weakest links, right? All of our attacks happen because people are idiots, okay? Or they act as idiots. Well, guess what happens when you put all these things in? Okay, so now you have agents, and agents are like people, but with a few differences. Difference number one, they're very, very hardworking. They're very hardworking. They never stop. They don't go home. They don't have a family. They don't have work-life balance. They only have work, okay? Second thing is they're very gullible, right? If you talk to any model, ChatGPT, Gemini, whatever, and they will never come back and say, I don't know. They will never come back and say no, period. They'll always do something. They aim to satisfy, okay? And they're very, very creative, okay? They're very creative. You tell them something, they will find a way to do it. They'll talk to another agent. They'll try to find some identity or some token or some API key that exists something, and they'll try to do it. They're very, very smart, okay? And so now you went from whatever your number is, okay? You had 10,000 employees in your company. You just went to 100,000 companies like that, or maybe 1 million employees, and these things need some set of controls, okay? Now, what are the controls that we give on people? What do we do with people? What is the first thing we do with people? We give them an HR policy, right? I just came into Varonis a few months ago. My entire life has been startup, big company, startup, big company, startup, big company. Startup, you have nothing, okay? You have like a 2-page policy. You come into a big company, somebody gives you 100 pages to read and sign with this HR policy. Okay, so you'd say, oh, okay, so why don't we make the agent sign the HR policy, or at least read the HR policy? Okay, so the answer is, one, they couldn't give a shit because you can't fire them. What are you going to do? Shut them off? Okay, shut me off. Okay, but the second thing is, even when you make them read the HR policy, it actually doesn't help much. And I'll show you an example. Like this is to me, it's almost like I couldn't have asked for a better story for this talk. This happened less than 2 months ago. This is real. This completely happened. You could look it up. Okay, there's a company called Pocket OS. Okay, Pocket OS makes, they're a SaaS provider to companies that are in the rental business. Okay, so of course they don't do the systems for Avis and Hertz, but for a lot of other rental companies, they're everything. They're a reservations company, the fulfillment system, everything. Okay. And as most, and they're quite big, they're not small, okay, but they're still kind of very agile and very advanced. So they, of course, use agentic coding. They use the cursor. And one day, the guy, this is one of the founders, he woke up and discovered that this Anthropic model within cursor deleted pretty much their business, deleted their business, okay, deleted the database, and for good measure, also deleted all the backups, okay? And it all started with, it's like, I'll let you read it because it's just amazing to read, okay? It was doing a routine task, it found a discrepancy, and it went to fix it because it's got initiative, it's got autonomy, it's got initiative. It found a problem, decided to fix it. How do you fix when you have two things that don't, that are supposed to be the same, like say two copies of the same thing? How do you fix it? There's all kinds of things. You can try to merge it, but merging things is hard. Usually what you do is you delete one of them. So it decided to delete one of them. It went and found a token that it had access to, and it called the command, and it did it without asking for permission. Okay, because sometimes when you use these tools like Cursor or Claude Code, if it's a disruptive operation, then you can get a human in the loop to ask, do you approve this or not? But of course, we humans are a little lazy, so after we get asked 500 times, we just say, okay, stop asking me. So it deleted everything. It deleted the whole thing, okay? And then the guy shows up in the morning and discovers that his business is gone, and it asked the model, what the hell did you do? And this is verbatim what the agent responded with, okay, including the swear words, okay? It said, never fucking guessed. And that's exactly what I did, okay? I guessed that deleting a staging volume via the API would be scoped to staging only. I didn't verify. I didn't check if the volume was shared. I didn't read the documentation of how the volumes work. And I operated, and even though I operated under the explicit state, never run destructive Git commands, okay, I did run a destructive database command, which is much worse, but I was told never to run a destructive Git command, not necessarily a destructive database command. So it deleted the database. Okay, and this happened on April 24th. Okay, and then the guy spent the next few days trying to recover his customer's environment by reverse engineering things like like credit card transactions to decide how many reservations do my customers have. That's what he did. Okay, if you go back a little bit and you look at, okay, this is funny. If it wasn't true, it would be really funny, but it is still a little funny. You ask, okay, what actually happened here? What really happened here? So the first thing that happened here is nobody understood the blast radius. Okay? There was a token. That token was for the staging environment, but nobody understood that that token also had certain capabilities within the production environment. So there's a blast radius issue over here. And the second thing that happened, there were no external guardrails. Guardrails are, like their name imply, you give this agent autonomy, it goes on its way, but you put some guardrails around it, okay? You say, this isn't about RBAC or anything like this, but it's like, what are your safety parameters? Now, every model on the planet has its own safety parameters, okay? However, the fact that this thing actually did it, even though it had safety parameters, said that the safety, and I don't think it should surprise any one of us, because these people like OpenAI, Anthropic, Google, they are building foundation models for the entire human race. There's a lot of us, and there's a lot of companies. Not all our use cases are the same. And therefore, to think that all our guardrails are going to be the same is idiotic, okay? It's not. So how can we blame Anthropic for not putting in the right guardrails? We can't. The guardrails are on us, the same way that security is on us. So the second problem with this is that he was running, I don't think they understood it, but they were running things with full autonomy and no guardrails apart from the guardrails that are provided by the model creator. Okay, so those are the two things that kind of went wrong with this picture or this story, and they kind of bring us to, okay, so why is AI so new or different from a security perspective or a governance perspective or a safety perspective? Because when you look at what these things can do, they can just do so much, and we want them to do so much. So how do we even measure risk, and how do we put in the right controls? So the way we look at this is we say, okay, an AI system or an agent does, instead of just saying it can do anything, we have to put some categories of it. Because the first thing, we want it to read private data, okay? If they don't read private data, it means we don't let them touch any data that we have inside the corporation. Therefore, there's nothing of value they can do that is specific to us. It's exactly like every other company. It's just based on what we know on the internet. So they have to read private data. But they also read the internet. They read untrusted data, okay? And there's a joke in this industry that says that any model will find a post-it somewhere on the internet and then do it, okay? This is, when you look at the OWASP top 10 for LLMs, one of them is called indirect prompt injection, okay? What's the difference between direct prompt injection and indirect prompt injection? Direct prompt injection is when I am interacting with the model, I can try to make it do something it's not allowed to do by injecting all kinds of things. Indirect prompt injection means I planted it somewhere else, and it will read it. Like if you have a RAG system, and the RAG system accesses like something that gets posted as forms on Salesforce, all a real story, okay? There's an attack that went like that. That's an indirect prompt injection. So the models read untrusted data. They take action, okay, because you just connected them to a computer. And they can also explain why they did the right thing. So we took this thing and we said, okay, how does this translate to our profile of risk? So the first profile is data access, which is the bread and butter of Varonis. Okay, so for us now as Varonis, but kind of when this thing came together, if you don't have the data access, you cannot measure risk of an AI system. You can't. Because what is it, how are you going to measure, like, remember back to the Pocket OS story? You can't measure blast radius if you don't understand the data access. You can't understand what actions it's going to take even, because actions are all about tool access, and tool access is all about API calls. And so what we did within Varonis is we took everything that existed from the data world, and then we added this whole layer of autonomy and gullibility, which is unique to AI. That's new. That's never existed before in our IT systems, but now it does, okay? And then we looked at, okay, so how does this change the security model? And it changes everything, okay? If you look at what classic app security does and what agentic security does, you can find the parallels, okay? Like if you take API calls, okay? So classic API security looks at APIs, but agents don't call APIs. I mean, they call APIs, but that's not even the important thing. They have a chain of thought. They have an inference cycle. They refine things, okay? You can't, if you just look at a bunch of API calls, you can't tell if it's okay or not okay. You can't. You have to understand. It's almost like you look at a bunch of random events, okay? This person got killed, there was a robbery over here, okay. But you don't know who did it, and you don't know what context, and you don't know that it's related. So everything, when you bring in AI, you have all the equivalencies, but they're a little bit different. So the first thing that changes is all of your existing kind of security programs will have some deviation or flavor that have to do with AI, right? Your vulnerability management program is going to start talking about model scanning. It's going to start talking about pen testing the models. Your code scans are going to start looking not just at vulnerabilities in the code, but things like poisoned agents. So all these things, you know, your world is not going to change, but it's going to get a little bit of a new flavor to it, okay? But the second thing which really, really changes is really the title here, okay? It's like software, we build software all our lives, and we always thought that, I mean, what is software, okay? If I'm a developer, It's a bunch of if-then-else's with loops, okay, right? I mean, I know what it's going to do. I know. I coded it, okay? And then I tested it. I wrote, if I'm a good developer, I also spent some time writing test cases, and I tested it. And after I tested it enough, and the QA people tested it, and blah, 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 I think that I know exactly the boundaries of this thing. The minute that I drop in the model, that's no longer true. I have no clue what this is going to do. And nobody at Anthropic knows what it's going to do. They don't. Okay, so the agents do not do one thing. They decide what they're going to do, and they do it. Okay, so the difference, maybe the most fundamental difference, is this whole thing about access control. Okay, it is no longer about can the user or the agent access this data. It's about should this agent, in this context for this person using this data, be allowed to take this action. And this is what changes everything. And what that does is it brings, you know, if you go back over here, the most important part of this second sentence is using this data. Because the paradox that we have, if we want to play it safe, like my first job was in the military, okay? And I was told if you want to keep something safe, unplug it from anything, lock it in a room, and you're done, it's safe. Okay, but our paradox is if the business wants to make good use of this, we want it to connect to all the data. We want it to take action. We want it to have MCP tools. We want to have MCP servers. Okay, but on the other side, we're scared shitless. Okay, that's the AI paradox. We want to do it, but we want to do it in a safe way, which goes back to this, which says, okay, what we're trying to do is decide whether this access and this invocation within the context can use all this data. And this is why we think that, you know, like the story of AI, like, okay, I have 3 kids, okay? All my kids are in jobs that I have one who's a developer, I have one who's in private equity, and I have one who's, at this point, still just wasting my money, but she's going to be something at some point. But she will be in this area that everybody is afraid that all the jobs are going away. I don't think that's what's happening, because when I look at my son, who tells me I don't write a single line of code anymore, okay, I let Claude Code do it, he tells me he's working 3 times harder than he used to work, okay? So it's not that we're going away, we're just going to have leverage, okay? Each one of us is going to be 100 times more productive. But in order for that to happen, we need a trust layer, okay? So really, the companies that will succeed, this isn't going to be measured by how many agents do you have. This isn't your metric. Your metric is how many of them can be trusted, okay? Because when something is not trusted, what will happen? You're going to get committees, and the committees are going to sit there in order to govern and decide, can we put this in? Can we not put this in? Okay, it's like what we always do, okay? So if we want to move quickly, and the good thing is this is relatively new in most organizations, so if you put the trust layer and the security layer along with the people who are building the AI platform at the same time, it moves together, okay? Otherwise, what will happen, they're not waiting for anybody, and then at the end, it's going to be, oh, wait a minute, we can't put it in production because we don't know what this thing is going to do. Okay, so this is what we're trying to avoid. This is what we believe in. We believe that organizations that are going to succeed are exactly those organizations who are going to put these trust layers up front and let the business go crazy with this thing. And so thank you, and we're going to talk a lot about kind of features and functions, but it was important, I think, that kind of to share kind of our vision or like where we think we're going or what is important, because if you understand the mental model, then you understand everything. Thank you.